Okay, here let's look at a couple of examples of finding the domain of a function. Example 1. Suppose our function is the square root of 3 minus x, all of that over x squared minus 4, and then that is added in turn to 1 over x. If we're after the domain of this function, and we presume that means the implicit domain of the function, we're after all of the possible values we could use as input x in this expression that are not going to cause problems for us. That is to say, they're not going to create undefined values, in some contexts, non-real values. So what are our problem values of x in this particular situation? The only way I could get something that's undefined with the operations involved in this expression would be to divide by 0. I've got two quotients here. I divide twice. Once by x squared minus 4, and another time I'm dividing by x. So certainly x equals 0 is a problem. That would create an undefined term here added to this, which would still be undefined. Also, if x squared minus 4, if that was equal to 0, that would be a problem as well. Now, of course, what values of x make that true? Well, that's the same question as what are the solutions to this equation, right? There's only one occurrence of x here. We could solve for it. That's x squared equals 4 if we add 4 to both sides. If we take a square root plus or minus on both sides, that reveals x is plus or minus 2. So I know I've got a problem here. I know I've got a problem at these two values. Both of those create undefined expressions or undefined sub-expressions of this whole thing. And those are problems. Now, what about the issue of our output being a real value? If I take the square root of a negative, that's a non-real value, right? I don't want that to happen. I need to ensure that whatever is under the radical, namely the 3 minus x, has to be bigger than or equal to 0. It can be 0 too. That's okay in this particular case because the radical shows up in the numerator. Had it been in the denominator, we would have a different story. So this has to happen for this to produce a real value output. Of course, that's easy to solve. Add x to both sides, and we get 3 is bigger than or equal to x. Now here again, note what's going on. This we want to happen. These two things we don't want to see happen. Those are problem values of x. Okay, let's think about our number line. We have just excluded 0, plus and minus 2, and we want to ensure that x is always less than or equal to 3. So let's see if we mark 3 here. 3 would be okay, and anything less than that is okay as long as it's not a problem value. So I have to jump over those guys. And what we have now is our domain. Okay, if I want to express this in interval notation, I've got the interval here from negative infinity up to negative 2. I can never include infinity or negative infinity, so we get a parenthesis there. I don't want to include negative 2 either. That's a problem guy, remember. I have the interval from negative 2 to 0. I don't want to include either one of those endpoints. They're both problem values. I've got the interval from 0 to 2. Again, I don't want to include either one of those values. They're problems. And then I've got the interval from 2 to 3. I don't want to include 2 because it's a problem value. I do want to and can include 3 because of that non-strict inequality. And of course, x could be taken from any one of these intervals, and this would be defined. It would be a real value. Everything would look great. So we'll indicate that we can have an x in any one of those intervals by throwing in those union operators there to couple them together. So that is the implicit domain of my function. Let's look at another one. Okay, example number 2. What about f of x equals -3 over the square root of 25 minus x squared? Okay, so here again we go through the same considerations. I want to make sure that this is defined everywhere. Of course, if I have divided by 0, I'm not going to have a defined expression. So one thing I need to worry about is if 25 minus x squared is equal to 0. That's a problem for me. Of course, this is fairly easy to solve. We would just square both sides. 25 minus x squared equals 0. We could isolate the x by moving it over to the right-hand side. So that's 25 equals x squared. We've added x squared to both sides. We could take a square root, plus or minus, and get plus or minus 5 is x. So I can see here immediately, plus or minus 5 have to be thrown out. They will not be included in the domain because they create an undefined expression. But additionally, I want this expression to be a real value, which means I can't have square roots of negatives, which means this piece under the radical, 25 minus x squared, that had better be greater than or equal to 0. Now notice I'm only going to write greater than 0 because I've already dealt with what happens when it equals 0 here. Okay, so this again, not too bad to find out which x values makes this true. We're looking at an inequality. We've got 0 on one side. We want this to be greater than 0. In other words, we want it to be positive. We can find out whether things are positive or negative by doing a sign analysis on the factors of this expression, which means we need to factor it. Okay, of course it breaks nicely into a difference of squares, 5 minus x and 5 plus x. It would have equaled 0, which again we would have thrown out over here, when x is -5, which makes this factor 0, or +5, which makes this factor 0. And we can test each interval, the results. If x is bigger than 5, like 6 or 7 or 1,000,000, this is certainly a positive value, but this is a negative value. So the product between those two things is going to be a negative. Inside here, from -5 to 5, a nice representative value would be 0. We can see this is going to be positive, and this is going to be positive. And so the product of those two things is positive. In this last interval, to the left of -5, like -6 or -7, that's certainly negative. 5 minus a -6 or 5 minus a -1,000,000, that's going to be positive. And the product is again a negative. Now, which ones of these do we wish to keep? Which intervals here do we wish to keep? We want the products that are greater than 0. So the positives. We don't want these. We want these. And we don't want these. And we don't actually want the -5 or the 5. Not so much, again, because it would cause a problem in taking the square root. We can take the square root of 0. That's going to be 0. But it would create an undefined fraction. It was handled already over here. Okay? So let's go ahead and put open circles in this case. Okay? So for this to be defined and real, we need to be in this interval from -5 to 5, and we can't actually be -5 or 5. So our interval is then -5 to 5 with parentheses on both here to indicate we're not including those endpoints. That's the domain. And we're done.